Okay, number 24. Number 24 says the combustion of ammonia in the presence of excess oxygen yields NO2 and H2O. Per that equation, 4NH3 plus 7O2 gives 4NO2 and 6H2O. The combustion of 43.9 grams of ammonia produces how many grams of NO2? First thing we notice here is there's only one piece of information. So this can't possibly be a limiting reagents problem, because a limiting reagent problem is going to have the amounts of both reactants. This one only has one. So we know this is going to be a quantitative information problem. We know one thing, and we can figure out how much of any of the rest of the reactants or products that are involved. Okay, we also notice that we start with grams. We know that doesn't work in stoichiometric calculations, and let's do something about it. The combustion of 43.9 grams. 43.9 grams, we are going to use the equality 1 mole is equivalent to the molar mass. The molar mass of ammonia is 17.03 grams. 17.03 grams. grams is 1 mole. Excellent. That's going to be our conversion factor, and we're going to take that equality and change it into a conversion factor, and we can put either one on the top or the bottom that we want to, or actually that we need to. We started out with 43 grams of NH3. The molar mass of that is 17.03 grams of NH3 is 1 mole. Excellent. That cancels with that. And 43.9 divided by 1703 is 2.577. 2.577 moles of NH3. Okay, now we have gotten to the point where we have moles. We know we can't solve with anything but moles, so now we really have the first part of this problem. So what we are going to have here is instead of grams, we're going to replace that with moles, and we'll end up with 2.577 2.577 moles of ammonia. Good. Okay, now we're starting with moles. We're going to find the relationship between ammonia and, what is it asking for? NO2. Good. 2.577 moles of NH3 is going to produce how much NO2? So in other words, what's the stoichiometric relationship between NO2 and the ammonia? Ammonia is 4 moles of ammonia is stoichiometrically equivalent to 4 moles of NO2. That cancels really. And we get 2.577 moles of NO2. That's how much NO2 is produced. Now, the problem asks for grams, though. So we'll simply back calculate that. 2.577 moles of NO2. And the conversion factor, we're going to be back to this right here. Only instead of 17 grams, NO2, 1 mole, weighs 46.005, 46.005 grams is the molar mass. Good, now that's equivalent to 1 mole, so moles go on the bottom. 1 mole of NO2 is stoichiometrically equivalent to, 1 mole of NO2 weighs 46.005 grams of NO2. And the moles of NO2 cancel, and what we end up with is 118 grams NO2.